Look up on a clear night and you'll see a few thousand stars scattered across the darkness. But that's just the tiniest fraction of what's actually out there. The observable universe contains at least 2 trillion galaxies, each one home to hundreds of billions of stars. And we now know that nearly every star has planets, many of them in zones where liquid water could exist, where life could take hold. The numbers are staggering. If even a tiny fraction of those worlds developed intelligent life, the galaxy should be teeming with civilizations. There should be radio signals crackling through space, massive structures reshaping solar systems, fleets of spacecraft cruising between the stars. And yet, when we listen with our most sensitive instruments, when we search with our most powerful telescopes, we hear nothing. The universe appears empty, silent, alone. So settle in. Let your mind drift toward the mystery. Tonight, we're exploring the Fermi Paradox, the haunting question that has puzzled scientists for decades. In a universe so vast and ancient, where is everybody? Look up on a clear night and you'll see maybe a few thousand stars scattered across the darkness. But here's something quietly astonishing. What you're seeing is just the tiniest fraction of what's actually out there. The observable universe stretches about 93 billion light-years across. Think of it as the biggest snow globe ever imagined, except instead of snow, it's filled with galaxies. How many galaxies? At least 2 trillion of them, each one a vast city of stars, spinning slowly in the cosmic dark. Our own Milky Way, which seems impossibly large to us, is just one grain of sand on an infinite beach, and each of those grains contains somewhere between 100 billion and 400 billion stars. The numbers become so large they stop feeling like numbers and start feeling like something else entirely, like the universe's way of whispering infinity. But let's make this a bit more personal. If you could count one star every second without stopping to eat or sleep or blink, it would take you over 3,000 years just to count the stars in our galaxy alone. That's longer than recorded human history, and remember, that's just our galaxy, just our cosmic neighborhood. Recently, we've discovered something remarkable. Planets are everywhere. For most of human history, we knew of only the few worlds circling our sun. But now we know that nearly every star has planets, often multiple worlds dancing around their parent suns in intricate cosmic waltzes. Some are gas giants, puffy and light as cosmic cotton candy. Others are rocky worlds like ours, with surfaces you could theoretically walk on if you had a very good spacesuit and an excellent sense of direction. Many of these planets sit in what astronomers call the habitable zone, that gentle region around a star where water can exist as a liquid. Not too hot, not too cold, but just right, like the cosmic version of Goldilocks finding the perfect porridge. In our galaxy alone, there may be tens of billions of these potentially habitable worlds. Imagine all those planets, some with oceans that have never known a single ship, some with skies that have never been looked up at by curious eyes. The math becomes almost overwhelming in its implications. If even a tiny fraction of these worlds developed life, if even a smaller fraction developed intelligent life, if even a microscopic portion of those became technologically advanced, the galaxy should be teeming with civilizations. There should be radio signals crackling through space, massive engineering projects reshaping solar systems, spacecraft cruising between the stars like cosmic highways filled with alien commuters. And yet, when we look out into that vast expanse, when we listen with our most sensitive instruments, when we search with our most powerful telescopes, we hear nothing. We see no signs of cosmic construction, no alien broadcasts, no fleets of interstellar ships heading our way. The universe appears to be a vast, empty mansion with all the lights off, and no one home. This silence becomes even more puzzling when you consider time. The universe has been around for nearly 14 billion years. Our Sun and Earth formed only about 4.5 billion years ago, making us relative newcomers to the cosmic neighborhood. That means there have been billions and billions of years for other civilizations to arise, to grow, to spread across the galaxy, to make their presence known. If intelligent life had emerged even once in our galaxy's early history, they would have had enough time to explore and colonize every star system multiple times over. They could have built networks spanning the galaxy, monuments visible from neighboring star systems, or simply filled space with the radio chatter of a billion worlds in conversation. So where is everyone? This question hangs in the cosmic silence like a mystery, neither threatening nor comforting, just beautifully, persistently there. It's a question that makes the night sky feel both more wonderful and more lonely at the same time. Let's narrow our focus to something more manageable. Our home galaxy, the Milky Way. The Milky Way is a spiral galaxy, shaped like a vast cosmic pinwheel, with arms of stars sweeping out from a bright central bulge. If you could see it from the outside, it would look like a slow-motion firework frozen in time, or perhaps a gentle whirlpool made of light. It's about 100,000 light-years across, which means that light itself, the fastest thing in the universe, takes 100,000 years to travel from one edge to the other. Our sun sits about halfway out from the centre, in what astronomers charmingly call the galactic suburbs. Not in the crowded, chaotic downtown, where stars jostle for space and black holes lurk, but not in the empty outer reaches either. It's a quiet neighbourhood, cosmically speaking. The kind of place where planets can form and life can take its time figuring things out without too much cosmic drama. The Milky Way contains somewhere between 100 billion and 400 billion stars. That's a range so vast, it's like saying there are between 100 and 400 grains of sand on a beach, then realizing each grain is actually a blazing sun. About 10% of those stars are similar to our sun. Not too big, not too small, not too young, not too old, just the right size and age to nurture planets for billions of years. And here's where things get interesting. Recent discoveries suggest that roughly 1 in 5 of those sun-like stars has an Earth-sized planet in its habitable zone. Let's pause and let that sink in for a moment. If only 1% of those potentially habitable worlds actually developed life, we'd still be talking about tens of millions of living worlds in our galaxy alone. But the Milky Way isn't just vast in space, it's ancient in time. While our solar system is about 4.5 billion years old, the galaxy itself is roughly 13 billion years old. That means there were star systems forming, planets cooling, and opportunities for life emerging for billions of years before Earth even existed. Imagine the possibilities that represents. While our planet was still a formless collection of cosmic dust, there could have been worlds where life had already taken its first tentative steps, from simple chemistry to complex biology. By the time the first fish were swimming in Earth's ancient seas, other civilizations might have been contemplating the stars and wondering if they were alone. Some of those early star systems had billions of years to work with. Billions of years for life to emerge, evolve, become intelligent, develop technology, and spread across their corner of the galaxy. If even one of those ancient worlds had given rise to a spacefaring civilization, they would have had enough time to visit every star system in the galaxy multiple times over. Think about it this way. Human civilization has existed for only a few thousand years, and already we've sent probes to the outer planets, walked on the moon, and seriously discussed missions to Mars. If we survive another 1,000 years, another 10,000, another million, what might we accomplish? What might we build? How far might we spread? Now multiply that potential by billions of years, and you begin to understand the scope of the mystery. The galaxy should be filled with the works and words of ancient civilizations, some perhaps so advanced that their technology would seem like magic to us. They might have reshaped solar systems, built networks of communication spanning thousands of light years, or simply filled space with the gentle background hum of a million worlds in conversation. Yet when we look out into our galactic neighbourhood with our best telescopes, when we listen with our most sensitive radio dishes, we see and hear nothing obviously artificial, nothing clearly made by intelligence. The stars burn quietly in their ancient patterns. The planets orbit in their silent dance, and space itself seems empty of voices calling across the void. This silence from our cosmic neighbours has a name, the Fermi Paradox. It's named after physicist Enrico Fermi, who reportedly asked this very question during a lunch conversation in 1950. Picture it: summer in Los Alamos, New Mexico. A group of physicists eating lunch together, discussing the latest science fiction stories about flying saucers and visitors from space. The conversation is light, perhaps a bit skeptical, the kind of chat you might have over sandwiches on any afternoon. Then Fermi, one of the giants of 20th century physics, asks a simple question that cuts through the casual speculation like a knife through butter. But where is everybody? It seems like such an innocent question, almost throwaway, the kind of thing you might wonder aloud while looking up at a starry sky. But contained within those 4 words is one of the most profound puzzles in all of science. If the universe should be teeming with life, if the galaxy should be filled with advanced civilizations, if space should be buzzing with signals and ships and signs of intelligence, then why do we see none of it? The question becomes even more pointed when you consider what we've learned in the decades since Fermi's lunch. We now know that planets are common, that the ingredients for life are scattered throughout the universe, that there has been plenty of time for intelligence to emerge and spread. By all reasonable estimates, we should not be alone. The universe should be anything but silent. This is what we now call the Fermi Paradox. Though it's not really a paradox in the technical sense, it's more of a profound discrepancy between what we expect to find and what we actually observe. It's the cosmic equivalent of expecting to find a bustling city and instead discovering empty streets and darkened windows. The paradox has only become more perplexing as our knowledge has grown. When Fermi asked his question, we knew of no planets beyond our solar system. Now we've discovered thousands of them, with new worlds being found regularly. When Fermi wondered about life, we had no idea how common the basic ingredients might be. Now we know that water, organic molecules, and energy sources exist throughout the galaxy. Every discovery that makes life seem more possible makes the silence more mysterious. Every new exoplanet in a habitable zone, every new moon with subsurface oceans, every new detection of organic molecules in space should increase the odds that we'll find evidence of life. Instead, each discovery seems to deepen the mystery of why we haven't found it yet. Let's play with some numbers. In our Milky Way galaxy, there are roughly 20 billion stars similar to our Sun. Not identical, but close enough in size, temperature, and lifespan to potentially nurture worlds like ours. Of those 20 billion Sun-like stars, recent observations suggest that about 20% have Earth-sized planets orbiting in their habitable zones. That's 4 billion potentially habitable worlds, just in our galaxy alone. 4 billion opportunities for liquid water to pool on rocky surfaces, for atmospheres to develop, for the delicate chemistry of life to begin its ancient dance. But let's be conservative, wonderfully, absurdly conservative. Let's say that only 1% of those worlds actually develop life. That still gives us 40 million living worlds. 40 million planets where something is growing, breathing, swimming, crawling, or perhaps thinking. Even if we're off by a factor of 1,000, even if life is far rarer than we imagine, we're still talking about tens of thousands of potentially living worlds. And here's where time enters the equation like a multiplier in a cosmic calculator. The Milky Way has been making stars and planets for about 13 billion years. Earth formed relatively recently, only 4.5 billion years ago. That means the galaxy had 8.5 billion years to experiment with life before our planet even existed. During those ancient eons, countless star systems formed, matured, and created the conditions for life. Some of those systems had billions of years more time than we've had. If we think of intelligence as a flower that occasionally blooms in the garden of life, then the galaxy has had billions of years for such flowers to bloom, grow, and spread their seeds across the cosmic landscape. Consider this. Human civilization, from our earliest cave paintings to our space telescopes, spans only about 10,000 years. In cosmic terms, that's less than the blink of an eye. If another civilization had even a million-year head start on us, they would be as far ahead of us as we are ahead of our Stone Age ancestors. If they had a billion-year head start, the gap would be almost incomprehensible. Such advanced beings might have technologies that seem like magic to us. They might be able to reshape matter at the atomic level, travel between stars as easily as we travel between cities, or communicate instantaneously across galactic distances. They might have built structures visible from thousands of light years away, or filled space with networks of artificial satellites and communication relays. But here's the thing about numbers: they can be deceptive. Large numbers can make something seem inevitable when it might actually be extraordinarily rare. Maybe the development of intelligent life requires such a precise sequence of events, such a delicate balance of conditions, that even with billions of opportunities, it's still vanishingly unlikely. Or maybe intelligence itself is common, but long-lived, technologically advanced civilizations are not. Maybe there's something about the nature of intelligence, or technology, or civilization itself, that makes it difficult to survive for the millions or billions of years needed to spread across the galaxy. The numbers tell us that something remarkable should be happening out there in the galaxy, whether it's billions of worlds teeming with simple life, thousands of planets with complex ecosystems, or even just a handful of advanced civilizations. The sheer scale of space and time suggests we shouldn't be alone. And yet, despite all these numbers, despite all these opportunities, despite all this time, the universe around us appears quiet, empty, waiting. The numbers say one thing, but the silence says another. In that gap between expectation and observation lies one of the most profound mysteries of our time. Time has a way of making everything feel both more possible and more mysterious. When we think about the age of our galaxy, 13 billion years, we're dealing with a span so vast that human language barely has words for it. But let's try to make it a bit more tangible. If the entire history of the Milky Way were compressed into a single year, Earth wouldn't form until late September. Complex life wouldn't appear until mid-December. Humans wouldn't show up until the last few minutes of December 31st. All of recorded human history would flash by in the final seconds before midnight. It's both humbling and oddly comforting to realize how young we are in cosmic terms. But what about all those months before September? What was happening in the cosmic calendar during the galaxy's long spring and summer? Stars were being born, planets were forming, and the conditions for life were slowly improving as the universe matured and cooled. In the galaxy's early days, things were quite chaotic. Stars exploded regularly in spectacular supernovae, bathing nearby systems in deadly radiation. Heavy elements, the stuff needed to build rocky planets and complex chemistry, was still relatively scarce. It wasn't the best neighborhood for delicate things like life to get started. But after 1 billion or 2 billion years, the galaxy began to settle down. Stars became more stable, heavy elements became more common, and the first truly habitable worlds began to form. Some of these ancient star systems had something we didn't: time. Vast, almost incomprehensible amounts of time. Imagine a planet that formed when our galaxy was only 3 billion years old. Such a world would have had 10 billion years to work with, more than twice the age of our entire solar system. If life emerged there even once, it would have had 10 billion years to evolve, to become complex, to develop intelligence, to create technology, to spread across its home system and beyond. 10 billion years is long enough for evolution to work miracles. On Earth, complex life went from simple cells to humans in less than 4 billion years. What might 10 billion years produce? What forms of intelligence might emerge given such vast stretches of time? What technologies might develop? What understanding of the universe might accumulate? Such ancient civilizations, if they existed, would be as far beyond us as we are beyond the first simple bacteria that appeared in Earth's early oceans. They might have evolved beyond the need for physical bodies, existing as pure information or energy. They might have learned to manipulate matter and energy in ways we can barely imagine. They might have spread not just across their galaxy, but found ways to influence the very structure of space-time itself. But here's something strange to consider. Maybe they're still out there, but so advanced that we simply don't recognize their presence. If you showed a smartphone to someone from the Stone Age, they might not even recognize it as technology. It might just seem like a strange, flat rock. Could we be surrounded by the works of ancient civilizations without even knowing it? Maybe what we interpret as natural phenomena are actually the products of engineering so advanced it appears indistinguishable from nature. Maybe the regular patterns we see in some star systems aren't the result of natural processes. but the work of beings who learned to garden on a galactic scale. Maybe the empty spaces between galaxies aren't empty at all, but filled with a kind of technology we're not sophisticated enough to detect. Or perhaps the silence we observe is itself meaningful. Maybe advanced civilizations do exist, but they've learned the value of discretion. Maybe they've discovered that broadcasting your presence across the galaxy isn't always wise. Maybe they've learned to be quiet, to observe rather than announce themselves, to watch younger civilizations from a distance. There's something both lonely and wonderful about imagining these ancient watchers, beings who emerged from their home worlds billions of years ago and have been observing the galaxy's slow development ever since. They might have watched our sun form from a collapsing cloud of gas and dust. They might have observed the first life appearing in Earth's early oceans. They might be watching us now as we take our first tentative steps toward becoming a spacefaring species. But time cuts both ways. The same vast spans that allow for the development of advanced civilizations also provide countless opportunities for disaster. Stars explode. Asteroids collide with planets, ice ages come and go, supervolcanoes erupt, species go extinct, maybe intelligence is common, but survival is rare. Even if a civilization becomes advanced enough to spread across multiple star systems, they still face challenges we can barely imagine. Galactic collisions, gamma-ray bursts, the slow but inevitable death of stars, the expansion of the universe itself. Maybe the galaxy is filled not with thriving civilizations, but with the quiet ruins of those who came before. Archaeological sites on a cosmic scale. Or maybe time itself is the answer to the paradox. Maybe advanced civilizations do exist, but they operate on timescales so vast that they appear static to us. Maybe they think in terms of millions or billions of years, making their movements and decisions so slowly that we simply don't notice them, like trying to observe the growth of a mountain or the drift of a continent. Life, when you really think about it, is a series of increasingly unlikely events. Each step from simple chemistry to complex consciousness represents a barrier that most matter in the universe never crosses. These barriers, which scientists call great filters, might explain why the universe seems so quiet despite having so many opportunities for life to develop. Maybe we've already passed the hardest tests. Maybe the very fact that we're here, thinking and wondering about our place in the cosmos, means we've overcome challenges so difficult that most potential life never makes it through. Is a comforting thought in some ways, suggesting that the hardest part might be behind us. Consider the first great filter, the emergence of life itself. We still don't fully understand how non-living chemistry first organized itself into something that could grow, reproduce, and evolve. It might have happened in warm tidal pools, around deep-sea vents, or even in space itself. But wherever and however it happened, it required an incredibly precise dance of molecules, a coordination of chemistry that might be far rarer than we imagine. On Earth, this transition seems to have happened relatively quickly in geological terms, within the first billion years of our planet's existence. But maybe we were extraordinarily lucky. Maybe most planets with the right conditions for life never quite get the chemistry to work. Maybe they remain forever on the edge of life, filled with complex organic molecules that never quite cross the threshold into true biology. Then came the leap from simple, single-celled life to complex cells with nuclei and specialized structures. This transition, which biologists call the emergence of eukaryotic cells, took nearly 2 billion years on Earth. 2 billion years of what seems like evolutionary stagnation, with simple bacteria dominating the planet, while more complex life remained just a possibility. When complex cells finally did emerge, they did so through an extraordinary process. One cell literally swallowing another, but instead of digesting it, learning to live with it in a mutually beneficial relationship. The structures we now call mitochondria, the powerhouses of our cells, were once free living bacteria that became permanent residents inside other cells. This symbiosis was so successful that virtually all complex life on Earth depends on it. But symbiosis is a delicate process, requiring precise coordination between different organisms. Maybe most attempts at such partnerships fail. Maybe the galaxy is filled with planets where simple life never learned to cooperate, never discovered the benefits of working together, and so remained forever simple. Another great filter might be the development of multicellular life. For billions of years, Earth was a planet of single cells, each one living independently. The transition to creatures made of many cells working together required new forms of organization, new ways of coordinating growth and function. It required some cells to sacrifice their individual reproductive potential for the good of the whole, a kind of biological altruism that might be rare in the universe. Even after multicellular life emerged, there was no guarantee of complexity. For hundreds of millions of years, life remained relatively simple. Basic plants, simple animals, nothing that would impress a visitor from space. The explosion of complex animal forms, with shells and eyes, and nervous systems, didn't happen until about 500 million years ago, nearly 4 billion years after life first began. Perhaps the greatest filter of all was the development of intelligence, despite billions of years of evolution, despite countless experiments in form and function, despite the emergence of everything from flowers to whales. Only one species on Earth has developed the kind of intelligence that can contemplate the stars and build tools to explore them. Intelligence might be much rarer than we think. It requires not just a large brain, but the right kind of brain, connected in the right ways, supported by the right social structures. It requires curiosity, the ability to imagine future possibilities, and the capacity to work together on projects that span generations. These might be extraordinarily rare combinations of traits. Even on Earth, intelligence almost didn't survive. Our species came remarkably close to extinction several times, with global populations dropping to perhaps just a few thousand individuals. A slightly different outcome in climate change, volcanic activity, or disease could have ended our story before it truly began. But we did survive, and more than that, we developed language, writing, science, and technology. We learned to pass knowledge from one generation to the next, to build on the discoveries of our ancestors, to imagine futures we could work toward. We developed agriculture, cities, and eventually the tools to explore beyond our home planet. Maybe this entire sequence, from the first self-replicating molecule to creatures capable of wondering about their place in the universe, is so unlikely that it happens only once in a galaxy. Or perhaps only once in the entire observable universe. Maybe we've won a cosmic lottery with odds so astronomical that we can barely comprehend our good fortune. If this is true, if we've already passed the great filters that eliminate most potential life, then our existence becomes even more precious and meaningful. We're not just lucky to be alive. We're impossibly, incomprehensibly fortunate to exist at all. We're the universe's way of understanding itself, its only known attempt at consciousness and curiosity. This possibility places an enormous responsibility on our shoulders. If intelligence is this rare, this precious, then our survival and flourishing becomes a matter of cosmic importance. Every choice we make about how to treat our planet, our species, and our future might echo across the galaxy for millions of years. But there's also something wonderfully hopeful about this idea. If we've already overcome the greatest challenges, if we've already passed through the filters that eliminate most life, then perhaps our future is brighter than we sometimes fear. Perhaps the hardest part of becoming a spacefaring civilization is behind us, and ahead lies nothing but possibility, growth, and the slow, patient work of spreading life and intelligence throughout the galaxy. But what if we have it backwards? What if the silence of the galaxy isn't because life is rare, but because something eliminates it just as it reaches the cusp of greatness? What if there are barriers ahead of us, challenges so difficult that most civilizations fail to overcome them? It's a less comforting thought, but one worth considering as we look out at the empty sky. Maybe the galaxy has been filled with civilizations like ours, species that developed agriculture and cities, science and technology, space travel, and dreams of spreading among the stars. Maybe they built radio telescopes and wondered why they heard no voices calling across the void. Maybe they asked the same questions we're asking now, felt the same mixture of wonder and loneliness when they contemplated the cosmic silence. And maybe, just as they reached the point we're reaching now, something went wrong. It could be something obvious, something we can already see looming on our own horizon. Climate change, nuclear weapons, environmental destruction, resource depletion. Maybe most civilizations never learn to manage their own success, never develop the wisdom to match their power. Maybe the same intelligence and creativity that allows a species to reshape their world inevitably leads them to reshape it in ways that can't sustain life. We can see how this might happen. As civilizations become more powerful, they gain the ability to alter their environment on global scales. They burn fossil fuels that change their climate. They build weapons that can destroy their entire planet. They consume resources faster than nature can replenish them. Maybe the transition from a planetary species to a spacefaring one is exactly when these pressures become most intense and most dangerous. Or maybe the filter is more subtle, something about the nature of intelligence itself. Maybe advanced technology inevitably leads to social fragmentation, to the breakdown of the cooperation and shared purpose that allowed civilization to develop in the first place. Maybe species become so specialized, so dependent on complex systems, that they lose the resilience to survive major disruptions. There's another more speculative possibility that's both fascinating and terrifying. Maybe there's something we haven't discovered yet, some new technology or scientific principle that seems promising but turns out to be catastrophically dangerous. Maybe most civilizations discover it, try to use it, and accidentally destroy themselves in the process. We can imagine what this might look like. Maybe it's an energy source that seems clean and limitless, but creates unexpected instabilities. Maybe it's a form of artificial intelligence that seems helpful, but ultimately replaces its creators. Maybe it's a method of faster-than-light travel that works perfectly, until it doesn't, taking explorers and their homeworlds with them into cosmic oblivion. The scary thing about this possibility is that we might not see it coming. The last words of every advanced civilization might be something like, "This new discovery will solve all our problems," followed by silence. But perhaps the most troubling possibility is that there are multiple filters ahead of us, a gauntlet of challenges that become progressively more difficult as civilizations advance. Maybe the transition to space travel is just the first test, followed by others we can't even imagine yet. Maybe each step toward becoming a truly galactic civilization requires overcoming new barriers, and the cumulative probability of success becomes vanishingly small. If this is true, then our current moment becomes incredibly important. We might be approaching the most crucial period in our species' history, the time when we either overcome the filters that have eliminated countless other civilizations, or join them in the cosmic silence. But there's also something empowering about this perspective. If we know about these potential filters, if we can see them coming, maybe we can prepare for them. Maybe awareness is the key to survival. Maybe the species that make it through are the ones that take the long view, that think carefully about the consequences of their choices, that learn to balance progress with wisdom. The great filters ahead of us, whatever they might be, aren't necessarily insurmountable. They're challenges to be met with intelligence, cooperation, and care. They're tests that we might actually be equipped to pass if we're thoughtful enough, wise enough, and lucky enough to recognize them in time. Have you ever had the feeling you were being watched? That subtle sense that eyes were upon you even when you couldn't see anyone there? Maybe that feeling, projected onto a cosmic scale, isn't entirely wrong. Maybe we're surrounded by intelligences so advanced, so careful, that they observe us without our knowledge, like researchers studying animals in their natural habitat. This idea has a name, the zoo hypothesis. It suggests that advanced alien civilizations do exist, but they've agreed among themselves to maintain a kind of cosmic preserve around developing species like ourselves. We're the animals in the zoo, living our lives naturally while being quietly observed by beings we can't detect and wouldn't understand if we could. It's not necessarily a sinister idea, despite how it might sound. Think about how we study wildlife here on Earth. We try to observe animals in their natural state, minimizing our impact so we can understand how they truly behave when they're not influenced by human presence. We create protected areas where endangered species can develop without interference. We establish ethical guidelines about when and how to intervene in natural processes. Maybe advanced civilizations have developed similar ethical frameworks on a galactic scale. Maybe they've learned that young intelligences need space to grow, time to make their own mistakes, freedom to develop their own unique perspectives on existence. Maybe interference, no matter how well-intentioned, ultimately harms more than it helps. This would explain the apparent emptiness of space around us. It's not that there's no one out there. It's that they've agreed to stay hidden until we reach some threshold of development, some level of maturity that qualifies us for contact. Maybe that threshold is technological, requiring us to develop faster than light travel or master nuclear fusion. Maybe it's social, requiring us to overcome war, inequality, and environmental destruction. Maybe it's philosophical, requiring us to develop a certain wisdom about our place in the cosmos. The zoo hypothesis would also explain why we don't see obvious signs of galactic engineering or massive alien civilizations. Maybe such things exist, but they're carefully concealed from species like us. Maybe the galaxy is crisscrossed with trade routes and communication networks that use technologies we can't detect. Maybe there are vast cities orbiting distant stars, but they're shielded or camouflaged in ways that make them invisible to our primitive instruments. It's a humbling thought in many ways. It suggests that despite our technological progress, despite our scientific achievements, we're still essentially children in cosmic terms. We're the equivalent of a newly discovered tribe in the Amazon, fascinating to anthropologists, but not yet ready for full integration into global civilization. But maybe that's not such a bad thing. Maybe being in the zoo means being protected, being given the chance to develop at our own pace without the pressure and potential contamination of contact with far more advanced beings. Maybe the galaxy's advanced civilizations have learned through experience that premature contact can be devastating for younger species. There are historical precedents here on Earth that aren't encouraging. When technologically advanced civilizations have encountered less developed ones, the results have often been catastrophic for the less advanced groups. Diseases, cultural disruption, economic exploitation, loss of independence and identity. Maybe galactic civilizations have seen this pattern repeat itself countless times and have developed protocols to prevent it. The zoo hypothesis also suggests a kind of cosmic loneliness that's different from simple abandonment. We're not alone because there's no one else out there. We're alone because everyone else has agreed to leave us alone. It's the difference between being forgotten and being given space to grow. One is tragic, the other is almost kind. Of course, this raises questions about the ethics of such arrangements. Do developing civilizations have the right to know they're being observed? Is it morally acceptable to withhold contact indefinitely? What if a species never reaches the threshold for contact? What if they destroy themselves while the watchers simply observe? Maybe there are disagreements among the galactic community about these questions. Maybe some civilizations favor early contact and intervention, while others insist on strict non-interference. Maybe the silence we observe reflects not universal agreement, but ongoing debate about how to handle species like us. There's also the question of what the threshold for contact might be. Maybe it's not just about technology or social development. Maybe it's about awareness itself. Maybe the test is whether we can figure out that we're being watched, whether we can develop the sophistication to detect their presence despite their efforts to remain hidden. In this scenario, our search for extraterrestrial intelligence isn't just scientific research. Is a kind of graduation exam. Maybe the moment we develop the tools and methods to detect advanced civilizations, despite their attempts at concealment, is the moment we demonstrate our readiness for contact. Or maybe the threshold is simpler and more fundamental. Maybe we need to prove we won't destroy ourselves. Maybe the galaxy is filled with the ruins of species who achieved great technological power, but never learned wisdom to match it. Maybe the Watchers are waiting to see if we can survive our own success, if we can learn to live sustainably on our home planet before we're trusted with access to the larger galactic community. But there's another possibility entirely, one that's both more mundane and more unsettling. Maybe the reason we don't see evidence of life throughout the galaxy isn't because it's hidden or destroyed, but because it's genuinely, extraordinarily rare. Maybe Earth isn't typical, but exceptional. A cosmic lottery winner in a universe where the odds of life are far lower than we've assumed. This idea, known as the rare Earth hypothesis, suggests that while simple life might be relatively common in the universe, complex life, especially intelligent life, requires such a precise combination of conditions that it's essentially unique. Maybe we're not just lucky to be here. Maybe we're impossibly, incomprehensibly fortunate. Consider what had to go right for us to exist. We needed a star of just the right size and age, burning steadily for billions of years without the dangerous flares or instabilities that characterize many stars. We needed to orbit at exactly the right distance, close enough for liquid water, but far enough to avoid being tidally locked or stripped of our atmosphere. But that's just the beginning. We needed a moon, and not just any moon, but one large enough to stabilize our planet's tilt and create the tides that may have been crucial for early life. We needed Jupiter, acting as a cosmic vacuum cleaner, sweeping up asteroids and comets that might otherwise have made Earth uninhabitable. We needed plate tectonics to recycle our atmosphere and regulate our climate over geological time. We needed the right kind of magnetic field to protect us from harmful radiation. We needed the right atmospheric composition, the right amount of water, the right distribution of continents and oceans. We needed ice ages that weren't too severe and warm periods that weren't too extreme. We needed thousands of factors to align in just the right way for billions of years. And even with all these advantages, the path from simple chemistry to complex intelligence was neither straight nor guaranteed. Life on Earth has faced multiple mass extinctions, events that wiped out the majority of species and could easily have ended the story entirely. We've survived supervolcano eruptions, asteroid impacts, ice ages, and dramatic changes in atmospheric composition. Maybe most planets don't have this combination of stability and dynamism. Maybe most worlds are either too stable, remaining locked in simple chemical cycles, or too chaotic, with conditions changing too rapidly for complex life to develop. Maybe the Goldilocks zone isn't just about temperature, but about countless interacting factors, each of which must be just right for billions of years. The rare Earth hypothesis also suggests that intelligence itself might be far more unlikely than we assume. Despite billions of years of evolution on our planet, despite countless experiments in form and function, only one species has developed the kind of intelligence that can contemplate the cosmos and build tools to explore it. Intelligence requires not just large brains, but the right kind of social structures, the right kind of environment, the right kind of challenges. It needs predators to drive the evolution of cleverness, but not so many that intelligence becomes impossible. It needs social groups large enough to support complex communication and culture, but not so large that cooperation breaks down. Maybe the conditions that produced human intelligence were themselves extraordinarily rare. Maybe the specific combination of climate change, social pressure, and environmental challenges that drove our ancestors to develop language, tools, and abstract thinking happens only once in a galaxy. Or perhaps only once in the entire observable universe. If this is true, then the silence we observe isn't mysterious at all. It's exactly what we should expect from a universe where complex life is incredibly rare, and intelligent life is rarer still. Maybe we're not looking at a puzzle that needs solving, but at a simple statistical reality. We're alone, because the odds of being anything else are astronomically small. This possibility is both humbling and empowering. It suggests that we're not just another species on just another planet, but something genuinely unique and precious. We're the universe's only known attempt at consciousness, its only known way of understanding itself, its only known source of art, music, love, and wonder. If we truly are rare, then our existence takes on cosmic significance. Every choice we make about our planet's future, our species' survival, and our potential expansion into space becomes a matter of universal importance. We're not just responsible for our own well-being, but for the continued existence of life and intelligence in the cosmos. But the rare Earth hypothesis also suggests that we shouldn't expect rescue, help, or guidance from advanced alien civilizations. If we face challenges like climate change, nuclear weapons, or environmental destruction, we'll have to solve them ourselves. There's no galactic community waiting to welcome us, no ancient wisdom to guide us, no backup plan if we fail. This places an enormous responsibility on our shoulders, but it also suggests that we might be more capable than we realize. If we're here despite impossible odds, if we've survived and thrived despite countless challenges, maybe we have the resilience and intelligence needed to overcome whatever obstacles lie ahead. There's something almost meditative about the radio silence, about tuning into the frequencies where alien civilizations might broadcast their presence and hearing nothing but the gentle static of cosmic background radiation. For decades now, we've been listening to the universe, hoping to hear something, anything, that would tell us we're not alone. The search has been both methodical and hopeful. Radio telescopes around the world scan the sky. Automated systems sift through vast amounts of data, looking for patterns that couldn't be natural, signals that could only come from intelligence. We've looked for narrowband transmissions, the kind that stars don't make naturally. We've searched for pulses and patterns, for the mathematical, signatures that might indicate a deliberate message, and the universe has been politely, persistently quiet. It's not that we haven't found anything interesting. Space is full of fascinating signals. Pulsars spin and beam radio waves across the galaxy like cosmic lighthouses. Quasars, billions of light years away, pump out enormous amounts of energy. The remnant radiation from the Big Bang itself whispers constantly in our instruments, a kind of cosmic background hum that tells the story of creation. But none of these signals show the characteristics we'd expect from intelligence. They're either too regular, like pulsars, or too chaotic, like solar flares. They can be explained by natural processes, by the physics of stars and galaxies and the fundamental forces of nature. What we haven't found is anything that requires intelligence to explain. The silence is particularly puzzling when you consider how easy it would be for an advanced civilization to make itself known. A simple radio beacon broadcasting a mathematical sequence or a recognizable pattern would be detectable across thousands of light years, with technology not much more advanced than our own. If anyone out there wanted to be found, we should have found them by now. Maybe that's the key word, wanted. Maybe the galaxy is full of intelligence, but none of it wants to be detected by young, potentially dangerous species like ourselves. Maybe the smart civilizations are the quiet ones. The species that learned early that broadcast in your location across the galaxy isn't always wise. There's a dark possibility hidden in the silence. Maybe the reason we don't hear from other civilizations is that they've all learned to be afraid. Maybe the galaxy contains predatory species, hunters who listen for radio signals and target any planet foolish enough to announce its presence. Maybe the universe is not empty, but filled with hidden intelligences, all keeping quiet to avoid attracting the wrong kind of attention. This would explain not just the silence, but the apparent lack of large-scale engineering projects, the absence of Dyson spheres or other megastructures we might expect from advanced civilizations. Maybe building anything too obvious, too detectable, is an invitation to disaster. Maybe the successful civilizations are the ones that learn to develop sustainably and quietly, leaving no trace that could be detected from afar. Or maybe the silence tells us something about the nature of advanced intelligence itself. Maybe truly advanced civilizations don't need to communicate across space because they've found better ways to share information. Maybe they've developed technologies that operate outside our understanding of physics, forms of communication that use quantum entanglement or dimensions we haven't discovered yet. Maybe the radio spectrum, which seems so logical to us as a way to communicate across stellar distances, is actually a very primitive approach, maybe trying to contact. Aliens with radio waves is like trying to reach someone across town by sending smoke signals when everyone else is using cell phones. There's also the possibility that advanced civilizations have simply moved beyond the need for electromagnetic communication. Maybe they've learned to encode information directly into the structure of space-time to communicate through gravitational waves or other phenomena we're only beginning to understand. Maybe the universe is actually buzzing with conversation, but we're listening to the wrong channels. Another interpretation of the silence is that it reflects the natural lifespan of detectable civilizations. Maybe species only broadcast for a brief period in their development, a few centuries or millennia, when they have radio technology, but haven't yet developed more sophisticated methods. Maybe we're in our broadcasting phase right now, but will eventually grow beyond it. If this is true, then the chances of two civilizations being in their radio broadcasting phases at the same time and being close enough to detect each other becomes vanishingly small. The galaxy might be full of intelligence, but they're all using communication methods we haven't developed yet. Yet there's something beautiful about our persistence in the face of this silence. Despite decades of hearing nothing, we keep listening. Despite the vastness of space and the apparent emptiness of the radio spectrum, we maintain our search. There's something touching about humanity's refusal to accept that we might be alone. Our continued hope that somewhere out there, someone might be trying to reach us. The silence of space isn't necessarily empty. It might be full of meaning we don't yet understand, full of signals we don't yet know how to detect, full of intelligences waiting for us to become sophisticated enough to join the conversation. Or maybe the silence is exactly what it seems, the sound of a universe where intelligence is so rare, so precious, so unlikely that it emerges only once in billions of years, in billions of star systems, leaving each conscious species to wonder if they're alone in the vast cosmic dark. Either way, the silence teaches us something important about ourselves. That consciousness is remarkable, that the universe's ability to understand itself through creatures like us is extraordinary, and that whether we're alone or surrounded by hidden intelligences, our existence is a kind of miracle worth protecting and celebrating. If we step back and look at all the possibilities we've explored, one thing becomes clear. Regardless of whether we're alone or surrounded by hidden civilizations, we carry an extraordinary responsibility. We might be the universe's only attempt at consciousness, or we might be one voice in a vast choir we haven't learned to hear yet. Either way, what we do matters on a scale that's hard to comprehend. Think about it for a moment. If the rare Earth hypothesis is correct, if intelligence truly is extraordinarily uncommon, then we're not just another species on another planet. We're the universe's way of understanding itself, its only known source of art and music, love and laughter, curiosity and wonder. Every human who has ever lived, every thought that has ever been thought, every discovery that has ever been made, represents something unprecedented in the cosmos. That's a staggering responsibility. It means that our choices about the future, our decisions about how to treat our planet and each other, have consequences that stretch far beyond our immediate concerns. If we destroy ourselves through war, environmental damage, or simple carelessness, we might be extinguishing the only light of consciousness in an otherwise dark universe. But even if we're not alone, even if the galaxy is filled with hidden intelligences waiting for us to prove our worth, we still carry a unique burden. We're the only human civilization there will ever be. We are the only species that will ever see the universe through human eyes, feel wonder with human hearts, reach for the stars with human dreams and determination. Our perspective is irreplaceable. Even if 1,000 other species have gazed up at the night sky and felt the pull of cosmic mystery, none of them felt it quite the way we do. None of them expressed it through human language, human art, human science. None of them brought to the universe our particular combination of curiosity, creativity, and stubborn hope. This uniqueness extends to our potential as well. If we survive and spread among the stars, we won't just be adding another voice to the galactic conversation. We'll be adding the human voice, with all its particular insights, perspectives, and ways of understanding existence. We'll be bringing something genuinely new to the cosmic community, something that has never existed before and will never exist again. But our responsibility goes beyond just survival. It extends to how we choose to live, how we choose to grow, what kind of civilization we choose to become. If we're being watched by advanced beings, if we're being evaluated for readiness to join a galactic community, then every choice we make is a kind of test. How we treat our planet, our fellow species, and each other says something about what kind of neighbours we might be on a cosmic scale. How we respond to challenges like climate change, inequality, and conflict reveals our capacity for wisdom, cooperation, and long-term thinking. How we explore space, whether with humility or arrogance, with respect or exploitation, shows what we might bring to the galaxy. The responsibility is enormous, but it's also empowering. It suggests that individual choices matter, that what each of us does contributes to humanity's cosmic story. Every act of kindness, every moment of curiosity, every effort to understand and protect our world becomes part of our species' resume for galactic citizenship. Maybe this responsibility is exactly what we need. Maybe the awareness that we might be unique, that our existence might matter on a cosmic scale, is what will help us overcome the challenges ahead of us. Maybe understanding our potential cosmic significance will inspire us to be better than we sometimes are, to think more carefully about our choices, to work more cooperatively toward our common future. There's something beautiful about the idea that we're not just living our individual lives, but participating in a cosmic experiment in consciousness. Every human achievement, from the first stone tools to the latest space missions, represents part of the universe's attempt to understand itself. Every work of art, every scientific discovery, every moment of love or compassion adds something precious to the cosmic story. If we're alone, then we're also irreplaceable guardians of something infinitely valuable, the spark of awareness that allows the universe to know that it exists. If we're not alone, then we're still unique participants in the most extraordinary story ever told, the story of a universe that gave birth to consciousness, and then watched that consciousness grow, explore, and reach back toward the stars from which it came. Here's a thought that might change how you see our future. If we really wanted to, if we pulled all our resources and determination, we could probably colonize the entire galaxy in about 2 million years. That might sound like an impossibly long time, but in cosmic terms is barely a moment. It's the blink of an eye, a single page in the vast novel of galactic history. The idea isn't as far-fetched as it might seem. We already have most of the theoretical knowledge needed to build generation ships, massive spacecraft that could sustain human populations for centuries or millennia while travelling between the stars. These wouldn't be quick trips. Even our fastest current spacecraft would take tens of thousands of years to reach the nearest star. But given enough time, enough resources, and enough determination, it could be done. Here's how it might work. Imagine building a spacecraft the size of a small city with closed-loop life support systems, artificial gravity, and everything needed to maintain a population of perhaps 50,000 people for several hundred years. This ship would head toward a nearby star system, taking maybe 1,000 years to make the journey. Once there, the colonists would establish a settlement, build infrastructure, and eventually construct new ships to send to other star systems. Each colony would become a launching point for further expansion. Instead of one ship heading to one destination, you'd have dozens of ships heading to dozens of destinations. The process would spread like ripples in a pond, or like life itself, branching and growing and filling every available niche. Even at this relatively slow pace, with journeys taking centuries and settlement periods taking additional centuries, the expansion would accelerate as more and more colonies joined the effort. It's exponential growth on a galactic scale. Within 2 million years, every star system in the galaxy could have been visited, explored, and potentially settled. 2 million years. In the context of the galaxy's 13 billion year history, that's nothing. If intelligent life had emerged anywhere in the galaxy even 10 million years ago, they would have had time to colonize the entire galaxy 5 times over. If they had emerged 100 million years ago, they could have done it 50 times. This timeline makes the Fermi Paradox even more puzzling. It's not just that we don't see evidence of advanced alien civilizations. It's that if such civilizations had ever existed anywhere in our galaxy, they should have had plenty of time to spread everywhere, including here. They should have reached Earth millions of years before humans even existed. Maybe they did. Maybe Earth has been visited countless times by explorers from distant stars. Maybe they established bases here, studied our early life, and moved on. Maybe the signs of their presence have been erased by geological processes, buried under millions of years of sediment and stone. Maybe they're still here, watching from a distance, so advanced that we don't recognize their presence. Or maybe the challenge of interstellar colonization is far greater than we imagine. Maybe the distances are too vast, the hazards too numerous, the energy requirements too enormous. Maybe most civilizations look at the stars and decide it's not worth the effort. Maybe they find ways to be content with their home systems, creating rich, fulfilling civilizations that never feel the need to spread beyond their sun's warm embrace. There are practical challenges we might not have considered. Interstellar space is not empty. It's filled with dust, gas, and radiation. A ship travelling at high speeds for thousands of years would face constant bombardment from microscopic particles that would gradually erode its hull and systems. The psychological challenges might be even greater. How do you maintain a coherent civilization across generations of space travel? How do you preserve culture, knowledge, and purpose across the vast emptiness between stars? Maybe the answer lies in different approaches to spreading across the galaxy. Instead of sending biological beings in ships, maybe advanced civilizations send information, beaming the patterns of their minds and cultures to distant stars where they can be reconstructed. Maybe they send self-replicating robots that can build new colonies and new robots at each destination. Maybe they find ways to travel that we haven't imagined yet. Techniques that make the galaxy feel small rather than impossibly vast. Or maybe time itself is the barrier. Maybe civilizations don't last long enough to complete such journeys. Maybe the social and technological challenges of maintaining a multi-star civilization are too great. Maybe species naturally fragment and evolve as they spread, becoming so different from their origins that they no longer think of themselves as part of the same civilization. There's also the possibility that galactic colonization is happening, but so slowly that we don't notice it. Maybe advanced civilizations are methodical, careful, taking thousands of years to fully explore and understand each system before moving on to the next. Maybe they're like cosmic archaeologists, studying each world in detail, preserving its history, protecting its life before establishing any presence. Maybe the galaxy is divided into territories we don't recognize, with different civilizations maintaining different regions, all so advanced and subtle that their borders and activities are invisible to us. Maybe we live in a preserve, a protected area, where young civilizations are allowed to develop without interference. The math of galactic colonization suggests that someone should have done it by now. The silence suggests that either no one has tried, or they've succeeded so completely that we can't detect them. Either possibility raises profound questions about the nature of intelligence, ambition, and survival on cosmic scales. Perhaps the most wonderful thing about the Fermi Paradox isn't that it might have an answer, but that it exists at all. Here we are, conscious beings, on a small world, orbiting an ordinary star, sophisticated enough to contemplate our place in the cosmos, and to realize that we don't understand it nearly as well as we thought we did. The question, where is everybody, contains within it so many assumptions about intelligence, communication, technology, and the nature of existence itself. It assumes that life naturally tends toward complexity, that intelligence naturally tends toward expansion, that advanced civilizations naturally tend toward detectability. Maybe some or all of these assumptions are wrong, and the real answer lies in directions we haven't thought to look yet. Maybe the universe is stranger than we can imagine. Maybe consciousness takes forms we wouldn't recognize, exists at scales we haven't considered, or operates according to principles we haven't discovered. Maybe what we think of as the fundamental constants of existence, things like the speed of light and the arrow of time, are more flexible than we realize, opening up possibilities for communication and travel that currently seem impossible. Maybe the galaxy is filled with intelligence, but it's intelligence so alien to our way of thinking that we simply don't recognize it as such. Maybe some civilizations evolved from silicon-based chemistry and think in terms of geological timescales, their thoughts unfolding over millions of years like slow-motion continental drift. Maybe others exist as pure information, as patterns in electromagnetic fields or quantum fluctuations, thinking thoughts we can't even imagine. Maybe some intelligences exist at the quantum level, consciousness that emerges from the strange behaviors of subatomic particles. Maybe others exist at cosmic scales, thinking thoughts that span light years and take millennia to complete. Maybe the universe is layered with consciousness at every level, from the quantum to the cosmic, and we're only aware of the narrow band that operates at our particular scale of space and time. The beauty of not knowing is that it keeps all possibilities open. As long as the universe seems quiet, we can imagine it filled with hidden wonders, secret civilizations, forms of life and intelligence that would astonish and delight us if we could encounter them. The silence preserves the mystery, maintains a sense that anything might be possible just beyond the reach of our current understanding. Maybe that's part of the point. Maybe the universe is designed to be mysterious, to always offer new questions, just as we think we're beginning to find answers. Maybe the Fermi Paradox is just one note in a vast symphony of cosmic mysteries that will keep us curious and humble for as long as we exist. There's something deeply human about our response to this mystery. We don't just accept the silence, we make up stories about it. We imagine zookeepers and great filters, ancient watchers and cosmic gardeners. We populate the empty spaces with possibilities because we can't bear to think of them as truly empty. We refuse to accept that we might be alone, because loneliness, even cosmic loneliness, goes against something fundamental in our nature. This impulse to imagine, to speculate, to dream about possibilities beyond our current knowledge is one of the most beautiful things about human consciousness. We're not content to simply exist. We have to understand, to connect, to find meaning in the patterns we observe. Even when those patterns seem to tell us we're alone, we keep looking for evidence that we're not. Maybe this curiosity itself is the answer to the Fermi Paradox. Maybe the universe is quiet not because it's empty, but because it's waiting for us to develop the right questions, the right tools, the right perspectives to join the conversation that's been going on all around us. Maybe contact isn't about them finding us or us finding them, but about us becoming the kind of beings who can participate in whatever cosmic community actually exists. The search for extraterrestrial intelligence changes us, even if we never find anything. It makes us think about what intelligence really means, what life really requires, what consciousness really represents. It forces us to examine our assumptions about the nature of existence and to remain open to possibilities we haven't considered yet. Every time we point our telescopes at the sky, every time we send signals into space, every time we wonder about the possibility of life among the stars, we're doing something extraordinary. We're participating in the universe's attempt to understand itself. We're taking matter that was forged in the hearts of dying stars and using it to contemplate the possibility of other matter in other places becoming conscious and curious. Whether we ever make contact with alien intelligence or remain forever alone with our questions, the search itself is transformative. It connects us to something larger than ourselves, something that spans the cosmos and encompasses all of time. It reminds us that we're part of a story that began with the Big Bang and continues through every star that shines, every planet that forms, every moment of consciousness that emerges from the cosmic dance of matter and energy. The Fermi Paradox might never be solved, and maybe that's perfectly appropriate. Maybe the universe needs questions that don't have easy answers, mysteries that keep us reaching beyond our current understanding, puzzles that remind us how much we still have to learn. In the meantime, we have the gift of wonder, the privilege of curiosity, and the extraordinary opportunity to be conscious participants in the grandest story ever told. As we drift toward the end of this cosmic journey, perhaps it's worth pausing to consider what this grand mystery might mean for us here and now, on our small blue world spinning quietly through space. The Fermi Paradox isn't just an abstract puzzle for scientists to solve. It's a mirror that reflects our deepest questions about existence, consciousness, and our place in the vast story of the universe. Whether we're alone or surrounded by hidden intelligences, whether we're early or late to the cosmic party, whether we face great filters ahead, or have already passed them behind us, one thing remains constant. We're here now, conscious and curious, capable of asking these questions at all. That itself is extraordinary, perhaps even miraculous. Think about the chain of events that had to unfold for this moment to exist. Stars had to live and die to create the heavy elements in our bodies. Planets had to form and cool. Life had to emerge from simple chemistry and slowly, patiently develop complexity. Intelligence had to evolve. Consciousness had to dawn. And civilization had to develop to the point where creatures like us could contemplate the cosmos and wonder about our place within it. Every one of these steps was unlikely, perhaps extraordinarily so, yet here we are, the products of billions of years of cosmic evolution. Matter arranged in such intricate patterns that we can think about matter. Energy organized in such complex ways that we can contemplate energy. Information processing systems sophisticated enough to process information about information processing. We are, in a very real sense, the universe waking up and becoming aware of itself. Through our eyes, the cosmos observes its own structure. Through our minds, it contemplates its own mysteries. Through our emotions, it experiences wonder, beauty, and love. We're not separate from the universe. We're the universe expressing one of its most remarkable potentials. This perspective changes how we might think about the silence we observe. If consciousness is rare, if intelligence is precious, if awareness is the universe's most unlikely and extraordinary achievement, then every moment of curiosity, every instance of wonder, every question we ask about our cosmic neighbours becomes infinitely valuable. Maybe the answer to "where is everybody" is less important than the fact that we're here to ask it. Maybe the search for extraterrestrial intelligence is less about finding aliens and more about understanding ourselves, our potential, our responsibilities as conscious beings in a universe that might desperately need consciousness to give it meaning. The Fermi Paradox teaches us humility. It reminds us how much we don't know, how many assumptions we make about the nature of life and intelligence, how vast and strange the universe might be compared to our current understanding. It keeps us curious, humble, and open to possibilities we haven't imagined yet. But it also teaches us about our potential significance. If we truly are rare, if consciousness is as unlikely as it sometimes seems, then we carry a responsibility that extends far beyond our immediate concerns. We're not just living our individual lives. We're serving as the universe's memory, its capacity for understanding, its ability to appreciate beauty and meaning. The paradox encourages us to think beyond our usual timescales and concerns. It connects our everyday choices to cosmic consequences, our local actions to universal significance. How we treat our planet, how we manage our technology, how we relate to each other, all become part of humanity's resume, for whatever role we might play in the larger cosmic story. Whether we ever make contact with alien intelligence or remain forever alone with our questions, we're still participants in something extraordinary. We're part of the universe's ongoing experiment in consciousness, its attempt to understand itself through creatures who can think and feel and wonder. Every scientific discovery, every work of art, every moment of compassion or creativity adds something to this cosmic conversation. Every time we choose cooperation over conflict, sustainability over exploitation, wisdom over short-term gain, we're helping consciousness thrive in a universe that might not have many opportunities for it. The silence of space, whether empty or full of hidden meaning, reminds us that consciousness is not guaranteed. It's not automatic, not inevitable, not permanent. It's something that emerges under special conditions and can be lost through carelessness or catastrophe. It's something to be treasured, protected, and shared. Maybe that's the most important message of the Fermi Paradox. Not that we're alone, or that we're not, but that we're here now, aware and wondering, capable of asking profound questions about existence itself. Maybe the universe doesn't need us to find aliens to justify our existence. Maybe it needs us to be thoroughly, completely, magnificently human, curious, creative, caring, and conscious. Whether the galaxy is full of intelligence or empty of everything but our own small light, we have the opportunity to be good ancestors, good stewards, good representatives of consciousness itself. We have the chance to ensure that the universe's experiment in awareness continues, grows, and spreads. whether through our own expansion among the stars or through other forms of consciousness we might help nurture. The great silence that surrounds us might be temporary or eternal, meaningful or empty, but our response to it, our refusal to accept loneliness without question, our determination to keep searching and wondering and reaching toward the stars, says something beautiful about what it means to be human, to be conscious, to be part of the universe's long journey toward understanding itself. In the end, maybe the Fermi Paradox isn't a problem to be solved, but a gift to be treasured, a question vast enough to make us think about our cosmic context, mysterious enough to keep us humble, and profound enough to remind us that consciousness, wherever and however it exists, is something worth celebrating, protecting, and sharing across the stars. Think about the chain of events that brought you to this moment, listening to these words about cosmic silence and cosmic possibility. Your ancestors survived ice ages and plagues, wars and famines. They made choices that led to other choices that eventually led to you. Every single one of them had to survive long enough to have children, or you wouldn't exist. Go back far enough, and your ancestors were fish crawling onto land. Go back further, and they were single cells in ancient oceans. Go back to the beginning, and they were atoms forged in the hearts of stars that died billions of years before Earth existed. You are the product of an unbroken chain of survival, stretching back to the origin of the universe itself. Not a single link in that chain was broken, not once did the process fail. And now, here you are, conscious and curious about your place in the cosmos. That's not just remarkable, it's miraculous. The Fermi Paradox reminds us of this miracle. It makes us contemplate our cosmic context, our responsibilities, our potential futures. It asks us to think about what kind of civilization we want to become, what kind of neighbours we might be in a galactic community if one exists, what kind of ancestors we want to be to future generations who might spread among the stars. The silence doesn't give us easy answers, but maybe easy answers aren't what we need. Maybe we need questions that challenge us, mysteries that inspire us, puzzles that remind us how much we have yet to learn and discover. The universe may be filled with hidden intelligences, or empty of everything but our own small spark of consciousness. We might be surrounded by watchers or alone with our questions. We might be approaching great challenges, or have already passed them. But whatever the truth might be, we're here now, aware and wondering, part of something extraordinary and ongoing. As you settle into rest tonight, perhaps you'll carry with you a sense of our cosmic context, an awareness of the mystery that surrounds us, a feeling of connection to the vast story of which we're all part. Whether we're alone or not, whether we're early or late to the cosmic conversation, we're participants in the universe's attempt to understand itself, and that makes every moment precious, every discovery significant, every act of curiosity and compassion a gift to the cosmos. The stars above us have witnessed billions of years of cosmic history. They've seen galaxies collide, planets form, and the slow dance of matter and energy across unimaginable spans of time and space. And now, for this brief moment, they witness us, looking back at them, wondering, questioning, dreaming of what might be out there in the darkness. Maybe someday we'll find the answer to Fermi's question. Maybe we'll detect that first signal, make that first contact, join that cosmic community we've been imagining. Or maybe we'll remain alone, the universe's only known consciousness, its only attempt at understanding itself. Either way, we're part of something magnificent. We're living at a moment when a single species on a small planet, orbiting an ordinary star, has developed the ability to ask fundamental questions about existence, to explore other worlds, to contemplate the possibility of life among the stars. We're witnesses to the universe waking up and beginning to understand itself. This perspective changes everything about how we might approach our future. Instead of thinking only about immediate needs and desires, we can think about our role in the cosmic story. Instead of focusing only on competition and conflict, we can focus on our shared responsibility as carriers of consciousness in a universe that might desperately need it. The universe has given us an extraordinary gift, the ability to wonder, to question, to explore, to love. Our responsibility is to use that gift wisely, to nurture it carefully, and to pass it on to whatever comes next. Whether that's our own descendants spreading among the stars, or other forms of consciousness we haven't imagined yet. The Fermi Paradox will likely remain a mystery for years, perhaps decades or centuries to come, and that's okay. The search itself has value. The questions themselves change us. The act of looking up at the stars and wondering, are we alone, connects us to something larger than ourselves. It connects us to every human who has ever looked up at the night sky and felt that same sense of wonder. It connects us to the future humans who will continue asking these questions long after we're gone. And it connects us to the cosmos itself, to the vast, patient universe that somehow, against all odds, produced creatures capable of contemplating their own existence. So sleep well tonight, knowing that you're part of something extraordinary, that your consciousness, your curiosity, your capacity for wonder are all precious gifts, not just to you or to humanity, but to the universe itself. Dream of distant worlds and ancient civilizations. Dream of the silence between the stars and what it might mean. Dream of the day when we might finally hear a voice calling back across the cosmic void. Or the day when we realize that our own voice might be the only one the universe has. Either way, we're here, conscious, curious, wondering, and in a universe as vast and ancient as ours, that itself is a kind of miracle. The great silence continues, the mystery remains, and somewhere between the certainty of being alone and the possibility of cosmic neighbours lies our future, whatever that future might hold. The stars are waiting, the questions remain, and the story of consciousness in the universe continues to unfold. One way or another, we're all part of that story, and that makes us, every one of us, participants in the most extraordinary tale ever told.